All right. All right, guys. I have to apologize from all of you and from my boss Hassan as well because I started late. Uh, the reason is the reason is that I just woke up. I'm sorry. I was doing a midterm last night all night till 5 a.m. So sorry for the inconvenience. Yeah. So in the class, uh, in the class, okay, in the class we just started learning about momentum. 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 Hmm. If you don't know about momentum, momentum is mass times velocity, which means momentum is a vector as well, right? But if I give you just this formulation, I can tell you. Basically, I gave you all the information about momentum. The thing is, momentum is another fundamental, uh, other fundamental laws of physics as well, like energy, right? So, like we have, I told you, we have conservative, conservative laws. First one was energy. The second one is momentum. This is this. Momentum is always conserved. And I mean that's a fundamental law. I'm just trying to think like why it's always conserved, but it's just the way it is. Just like let me think. Uh, actually, the basic principle is this. Look, I don't know if you guys know, but like kinetic energy is 1/2 mv squared, right? Um, um, let's see. Mv squared. Okay, never mind this. I forgot how to do the momentum equation, but like, wait, I'm just gonna give you this. Kinetic energy is also can be written as P squared over 2 I. Therefore, in a system, you can say if there is only kinetic energy. And we know that energy always energy is always conserved, then momentum is always conserved as well. This was the initial thought. Yeah. Where's it from? Huh? Anyhow, so this was the original thought. Then, I mean, momentum. Yeah, I should put it in the beginning, but anyways, momentum was uh, in BC by the Greeks. By the Greeks, you know, what was the name? Galileo. I mean, Galileo is Galileo Greek, I guess so. Ar- Archimede, or I don't know, Greeks, Plato and stuff. Uh, so like what I'm trying to say is really fundamental. Like people before century actually thought about this thing. Then so momentum is conserved, right? Therefore, like uh, Newton's forces, you have um, yeah. I mean, what I'm trying to say is P initial equals P final. That's what it means by conservation. Okay. 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 So, sorry, I was thinking something else. So, uh, there are two types. So, okay, momentum. We talk about momentum. Alright. Then where we use it collisions. Collisions, right? You have like if you have two things coming against each other, or one thing standing and one thing is moving, trying to impede and stuff, like and these types of things. And those are things. There are two types of collisions. Two types of collisions. One, elastic collision. Two, inelastic collision. What is the difference in elastic collision? Is not conserved in inelastic. Okay. How can you tell, like, if it's conserved, if it's not conserved? You know. The thing is, elastic collision means something is conserved, right? But inelastic collision is not conserved, which means actually you lost energy, or not lost, but you transferred energy to somewhere else, like surrounding or heating the thing that you collided with, or like the friction, if there was friction, these kinds of things. It's inelastic. And so, if we go to problems, like there are multiple types of problems, like you have a ball going to the right, you have a ball going to the left. This is a mass 1, this is a mass 2, this is a V1, this is a V1 prime. To differentiate, right? So, we know momentum is conserved. Therefore, we always write P initial equals P final. Don't forget, these are vectors, right? Therefore, in this collision, you say right is positive if you want to, or left is positive. It doesn't matter. So, what do we have? We have initial P, M1, V1, plus M2, but V1 is going to the left. We say right is positive, therefore this is minus V1 prime equals, what's going to happen after? That's the thing, like you have to predict the future as well, like what's going to happen after the collide. So this is a head-on collision, right? Therefore, but this thing can happen. Look, after they meet up and they may reverse their directions. This becomes a 1, this becomes a 2. Right? Or at the end they give you the problem. So if this thing happens, what's going to happen next? Your M1 velocity changed. Therefore, now your M1 and minus V2, right? because change direction. M2 becomes plus M2 V2, right? Can you also you don't know, right? Uh, There's another possibility. For example, you have a ball and you have a small ball, and this comes here. This station, and like again, M1 and 2 should be one. And what's gonna happen after? Again, P initial equal P final, and therefore what's gonna happen is we know P initial, right? P initial is M1 V1. Second ball doesn't have any momentum because it's standing still, so velocity is zero. Therefore, the whole P2 is zero. What's gonna happen next? Next, this ball will come and hit the small ball. And imagine they're colliding. Yeah, and like they're moving together. And to can you see what's gonna happen? In this case, we will treat these two like whole body. Alright? Therefore, we become M1 plus M2, being the whole body, and times V2. I think it becomes so easy. Alright. Um, what else? Just some coffee. Ah. Mm. Let me check something. Alright, alright. So let me say something. This is basically one dimension. If you go to second, two dimensions. Same thing. Just you have X and Y, right? Therefore, what's gonna change? Nothing. Just you have to write two of the conservation and momental equation. One for the X Now for the y, initial, equals, p final x p final y. That's it. Like that's basically all. I mean, momentum is a very easy concept, fundamental. Like for example, there will be okay. No, imagine. Okay, imagine we're playing pool. Imagine we're playing pool, and there's a this is the white pool, M1. This is M2. This hits on this side, and from this, one goes here, one goes here, M2, M1, right? M2 standing still, with zero here. This is a V1, this is a V1, this is V2, this is a V2 prime. Ah, so, so, uh, so we have a ball and we're gonna, I mean, this ball will come and hit the other ball and they will separate like this, right? And then imagine this is theta and this is p. I mean, different angles. And what's gonna happen? Even though it looks complex, just write the equation, right? P initial x equals p initial y. No, p final x. P initial y. P final y. From here, as we can see, P initial is just V1 because V2 is 0. From here, as we can see, P initial Y is 0 because there is no moment in the beginning. This is X, this is Y. Positive. Yeah, forward, there's no moment. Moment. Alright, when it comes to second part of the problem, right, finals, what do you have in the final? Like for example, if I'm asking you what is we want, I mean, they don't ask you what is we want, to be honest with you. Like they'll ask what is V2, V2. Alright, what is P final X? It is V2 times cosine of phi plus V2 prime times cosine of theta. You see? You have to use the angle because you know you really care about this component of the both things in the x. And they have y like this, right? Um, Therefore, for y, pfy is just v2 sine phi minus v2 prime cosine sine sine theta. Y minus because up is positive, down is negative, right? Okay. Okay. I if one of my V2. Okay, V2. But I don't have any numbers though. Like it's gonna be pain in there somewhere. Actually, not really. Because like in the end, what's gonna happen? What's gonna happen is that you will say, as we said, P initial equals P final in X. Therefore, which means M times V1 equals to M1 of course, M1 times V2 cosine P plus V2 prime cosine theta. P initial equals P final y 0 should equal M1 V2 sine phi minus M2 V2 prime sine theta. This is what M2. Okay. For M1 V2 sine phi equals M2 V2 prime sine theta. I mean, that's from this you can find whatever you want, and it's two-dimensional. I mean, it's not even just this equation. The only equation is this: P initial in X equals P final in X. P initial in Y equals P final in Y. That's all. Again, I'm so sorry about the, being late and other stuff. On Sunday will be perfect. Thank you for everyone though. Like, no one showed up by now, but spring break.